So let's get an introduction to GeoGebra. GeoGebra is this amazing free online math program you can do all sorts with. If you're taking algebra, it has all sort of graphing, geometry. What we're going to be using, if you go to geogebra.org, is under classic apps, we're going to be using two spots throughout the term, spreadsheet and probability. What we're doing right now is inputting data and evaluating it, and that's what spreadsheet's going to be best for. So if we click on spreadsheet, it's going to open up this new window, and it's going to look a lot like Microsoft Excel. It's going to be that spreadsheet view. Sorry, my computer's a little slow. Let's see. So you'll see the spreadsheet open up. Here's going to be some tools that we use, which really we won't use these other ones, mostly this graph symbol right here that looks like our histogram. This window opens up too if you want to get rid of this, just to kind of make things look cleaner. If you go over to this upper right hand corner, there's this 3 bars, and that's our menu. And what you can do is go to View, and we want to see Spreadsheet, but it's this graphics window. If you just unclick that, it'll get out of the way and just makes things look nicer, but it won't mess up your math or anything. If you want to close this down, you can click the 3 bars again. Something else that's in here that'll be useful is if you go down to settings, sometimes GeoGebra will round a little bit too much. We're going to use a general rounding rule to 4 decimal places. As you can see, GeoGebra is rounding to 2. What you can do is if you go to the settings menu and just change that to 4, and you can save settings. That'll just make things easier as you work through everything else. It'll round further, so you'll have more accuracy. So, getting into what we want to do with making graphs and finding those statistics. So using that data that we looked at with those exam scores, what we want to do is in column A, we just want to type in all of that data. So type it all into the same column. And once we have that in there, a nice little thing you can do to double check, I know I should have 15 values, and we landed there at 15. So what we want to do in order to make our graph is you want to highlight the data, which you can drag over it, or what I often do is just click that column title, and that'll highlight the whole column. Once we highlight our data, we want to click the histogram symbol. What we're going to be doing is one variable analysis, the idea that we're evaluating a single numerical variable, in this case, exam scores. So if we click that, what it will do is automatically open up a histogram. So there's our histogram. What you'll notice is it looks a little different, and it's because of where it's starting at and the class widths that it's using. So something we want to understand how to do is how to adjust these to make a histogram look better. Like this is fine, but we could see more if we made smaller class widths. So in order to do that, at the top here, there's this kind of dragging bar, and just to the right of it is the options menu. So it's this little wheel thing. So click on options, and what you'll see is a list of these options here, and we want to click set classes manually. This is going to let us set the bin widths. So these two windows open up, the starting window and the width. So what we could do is change where we start, but let's just keep it at starting at 0, or we could go ahead and jump up to start at 30. So we'll have our starting point at 30, and then our bin width, to match what we used, we were using a bin width of 10. So now it just shows us a little more information here. So that's going to be a useful tool to making a graph clearer. You can go to set classes manually and adjust those two values. Where we see this word histogram in the upper left-hand corner, you can bring down this drop-down menu, and there's all these options here. Stem and leaf plot, you can get an idea, and if it's not showing you how it matched up, like this doesn't match how we did it, but if we click that -1 now, it brings out all those values. What you'll notice is with the stem and leaf plot, you can see the 31 was kind of disconnected, and it's because it's an outlier. So with GeoGebra, it will remove the outliers from the actual stem and leaf plot. There's the dot plot, which they kind of do this floating dot plot, kind of way elevated above that number line, which is what we're not necessarily doing. And then there's the box plot. And this shows exactly, it's going to calculate outliers the same way that we do, and it places the lines at the same spots as we do. So this is a great way to double check if you're making any graphs by hand, grabbing this to double check. What you can do with this too is like for a greater problem set or project, if you want to copy graphs, you can, there is this export feature, but I've heard from students that it actually causes a lot of issues and doesn't work all the time. So what I recommend doing is just doing a screen grab, either using your print screen button on your computer, which automatically grabs the complete screen and you can copy and paste it. You just hit print screen and then you can paste it into any document. Or I know Microsoft as well as Macs, I don't remember the name of the tool for Macs, but there's a thing called a snipping tool. And with this, you can click new and just grab what you want to copy and paste into a document. So that's how you can copy and paste graphs. So that's how we make our graphs. Then the other thing we want to look at is how do we get our statistics? Because especially calculating the standard deviation by hand each time is a lot of work. And what we want to do is be able to use technology in order to do that for us. So up in this upper right hand corner, you'll see the sigma x, and if you hover over it, it says show statistics. We click that, it'll show us all of the statistics that we want. So n is our sample size, tells us our mean, and then you'll see we have our two symbols for standard deviation. We have our population standard deviation and sample standard deviation. Never ever use the population standard deviation. We're always working with sample data, so we don't want to use that first value. Always use S. That's the accurate standard deviation using that formula that we learned. Sigma x and sigma x squared aren't really going to come up for us, but down here we have our minimum, quartile 1, median, quartile 3, and maximum. So there's our 5-number summary right there at the bottom. So this is going to be great for exams and such when you just need the numerical values and it really isn't about calculating by hand. Just plug in the data and get these statistics out.